The Voyager 1 spacecraft, launched in 1977, was tasked with a 36-year mission to explore strange new worlds, seek out anomalous cosmic rays, and study new forms of plasma in space. It aimed to boldly venture into areas where no probe had gone before. Over the past 4 decades, Voyager 1 has journeyed through outer space, surpassing every expectation and redefining what space exploration is capable of. Originally designed to survive only 5 years, it has far outlasted that time frame, continuing to transmit groundbreaking data. Recently, Voyager 1 made an astonishing discovery, detecting unknown objects passing by in the vastness of space, a finding that has fundamentally changed our understanding of the universe. The plasma detected by the spacecraft is thought to have originated from the explosive remnants of giant stars that died millions of years ago, carrying with it the magnetic field of the galaxy. The significance of this discovery is monumental, prompting scientists to rethink many of their assumptions about the nature of the cosmos. As we delve deeper into this mystery, we may uncover new aspects of interstellar space that could reshape how we view the universe and our place within it. In recent years, most of the data collected by Voyager 1 has focused on the solar system. However, with its continued journey into interstellar space, Voyager 1 has now provided us with unprecedented access to data from outside the solar system as well. In August 2012, Voyager 1 crossed the heliopause, the outermost boundary of the solar system, venturing into uncharted interstellar space. Yet, this achievement came with significant challenges. One of the most critical issues was the gradual reduction in available power. As Voyager 1 moved farther from the Sun, the amount of sunlight it could use to power its instruments diminished. The spacecraft relies on 3 radioisotope thermoelectric generators, RTGs, which generate electricity by converting the heat produced from the natural decay of plutonium-238. However, as the plutonium decays, the heat output from the RTGs decreases, leading to a steady decline in available power. This reduction in power has direct consequences for the operation of the spacecraft's systems. Scientific instruments, data transmission, and communication capabilities are all affected. In response, NASA engineers have had to deactivate non-essential systems and place certain instruments into dormant states to conserve energy. As Voyager 1's power supply continues to dwindle, critical systems may also need to be further optimized or shut down to prolong the spacecraft's operational lifespan. Yet even if the spacecraft continues to function, the immense distance between Voyager 1 and Earth poses its own challenges. Currently, it takes over 21 hours for signals to travel from Voyager 1 to Earth, and the signal strength is significantly weakened due to interference from cosmic background noise. This makes successful data transmission and reception increasingly difficult as time goes on. Another major challenge for Voyager 1 is the extreme temperature conditions it faces as it travels farther into interstellar space. While the spacecraft was within the heliosphere, the bubble of space influenced by the Sun's solar wind, it experienced relatively higher temperatures due to its proximity to the Sun. But as it crossed into interstellar space, it encountered extremely low temperatures, testing the spacecraft's materials and systems to their limits. The constant thermal expansion and contraction cycles caused by these extreme temperature fluctuations can create significant stress on the spacecraft's structural components. Materials that were durable in the warmer environment closer to the Sun may become brittle in the deep cold of interstellar space, increasing the risk of fractures or the degradation of seals and connectors. These temperature variations also influence the performance of the RTGs, which are designed to function within specific temperature ranges. As the RTGs cool, their power output decreases even further, exacerbating the spacecraft's already limited power supply. However, temperature is not the only environmental factor impacting Voyager 1. Although interstellar space is often thought of as empty, it actually contains a sparse distribution of dust particles. These particles, though tiny, pose a significant risk to the spacecraft. Over time, collisions with these particles can cause wear and tear on Voyager 1's exterior surfaces, particularly the protective coatings on the spacecraft's antennas and sensors. If enough dust accumulates on these sensitive areas, it could interfere with the spacecraft's ability to collect and transmit data accurately. Voyager 1 is equipped with a dust detector designed to measure the density of interstellar dust, but the presence of dust still presents a risk. Additionally, NASA's Deep Space Network, DSN, which is responsible for maintaining communication with distant spacecraft, has to prioritize its limited resources. As a result, communication opportunities with Voyager 1 are less frequent than they once were, further complicating efforts to retrieve data from the spacecraft. Despite these challenges, Voyager 1 continues to transmit valuable information. Recently, amidst the stream of data sent back to Earth, scientists detected something extraordinary, a strange anomaly. Voyager 1 had detected signals indicating the presence of 300 unknown objects passing through the vast reaches of interstellar space. This unexpected discovery left scientists puzzled. The detection of these mysterious objects challenges our understanding of the universe. Could they be remnants of ancient celestial bodies drifting through space, or do they represent entirely new phenomena that have never been observed before? The answers to these questions remain unclear. Decoding the data sent by Voyager 1 proved difficult. Unlike most of the information transmitted by the spacecraft, which is typically easy to decipher, this new data was scrambled, making it challenging to interpret. Scientists were left with more questions than answers. However, despite the scrambled nature of the data, Voyager 1 itself appeared to be in good condition, continuing to function normally. The spacecraft's communication link with Earth remained intact, and it continued transmitting valuable information without significant issues. In response to the strange signals, NASA's research team began investigating the possible causes behind the scrambled data. They considered a range of potential explanations, from interference caused by cosmic radiation to the impact of temperature fluctuations on the spacecraft's electronic components. The team meticulously examined Voyager 1's systems, paying close attention to the spacecraft's communication systems, which could have been affected by cosmic noise or even subtle changes in its trajectory. After weeks of investigation, the team finally identified the source of the problem. The anomaly was traced back to Voyager 1's Attitude Articulation and Control System, AACS, which had unexpectedly started using a dormant onboard computer that had been inactive for years. This malfunction had caused the spacecraft to transmit corrupted data. Once the issue was identified, NASA engineers sent a command to Voyager 1, instructing the AACS to switch back to the correct computer for data transmission. While the fix was relatively straightforward, it required a great deal of patience due to the significant time delay involved. With radio signals taking nearly 22 hours to travel between Earth and Voyager 1, troubleshooting was a slow and meticulous process. Complicating matters further, Voyager 1 was built decades ago, and many of the spacecraft's systems are based on technology from the 1970s. To resolve the issue, NASA engineers had to consult old manuals from the time of the spacecraft's construction. Fortunately, the engineers were able to come up with a simple and low-risk solution. By resetting the system responsible for transmitting data, they restored clarity to the signals being sent from Voyager 1 without affecting any other parts of the spacecraft. This successful fix highlighted the importance of combining past knowledge with modern technology to solve challenges in space exploration. With the communication issue resolved, Voyager 1 continued its groundbreaking mission, making history by crossing the heliopause, the boundary marking the outer reaches of our solar system. The heliopause is where the Sun's solar wind meets the interstellar medium, the vast space between star systems. Located about 123 astronomical units from the Sun, roughly 11 billion miles, this boundary marks the edge of the heliosphere, the region dominated by the Sun's magnetic field and energetic particles. Crossing the heliopause was a monumental achievement for Voyager 1. Upon crossing this boundary, the spacecraft experienced a significant drop in the temperature of solar wind particles, which occurs as the spacecraft moves beyond the influence of the Sun's direct emissions. Additionally, Voyager 1 detected a change in the direction of the magnetic field, reflecting the altered influence of interstellar magnetic forces. Perhaps most significantly, there was an increase in galactic cosmic rays, high-energy particles from distant sources, which become more prominent beyond the heliopause. In November 2018, Voyager 2 followed its twin spacecraft across the heliopause, providing further insights into this mysterious boundary. Interestingly, Voyager 2's observations differed from those of Voyager 1. While Voyager 1 encountered precursor events before crossing the heliopause, Voyager 2 did not. Instead, Voyager 2 detected a distinct boundary layer just beyond the heliopause, where low-energy particles streamed outward from the Milky Way. This finding highlighted the complexity of the interstellar boundary and suggested that the experience of crossing it may differ depending on the spacecraft and the exact conditions in that region of space. Despite the challenges posed by the heliosphere and the uncertainties of interstellar space, NASA remains determined to push the boundaries of space exploration. In fact, the agency has ambitious plans for a new mission, the Interstellar Probe. This concept, first proposed in 2018, aims to go even further than the Voyager spacecraft. Scheduled to launch between 2036 and 2041, the Interstellar Probe will embark on a journey spanning several decades and hundreds of astronomical units, gathering comprehensive data on the heliosphere and the region beyond. The Interstellar Probe represents a significant leap forward in interstellar exploration, utilizing cutting-edge technology to advance our understanding of space. Its primary mission will be to gather detailed measurements of the conditions in the heliosphere and the heliosheath, the outermost layer of the Sun's bubble of charged particles, before venturing into interstellar space. There, the probe will continue to study the interactions between our solar system and the surrounding galaxy, much like Voyager 1, but with far more advanced instruments. As we look to the future, the legacy of Voyager 1 and its incredible discoveries endures as a testament to human ingenuity, resilience, and curiosity. The spacecraft's unexpected longevity and groundbreaking achievements have paved the way for future missions and inspired generations of scientists and explorers. With each new milestone, we come closer to unraveling the mysteries of the universe and understanding the vast, awe-inspiring expanse of space that surrounds us. As Voyager 1 continues its incredible journey into the unknown, it serves as a powerful reminder of the endless possibilities that lie beyond our planet. The discoveries it has made, from detecting mysterious objects in deep space to crossing the boundary of our solar system, push the boundaries of human knowledge and fuel our collective curiosity about the universe. But this is just the beginning. There's so much more to explore, and the future of space exploration is brighter than ever. If you're as fascinated by these cosmic mysteries as we are, make sure to subscribe to our channel. Stay up to date on the latest discoveries, space missions, and the awe-inspiring advances in science and technology that are reshaping our understanding of the universe. By subscribing, you'll be joining a community of explorers, dreamers, and learners who share a passion for unlocking the secrets of space. So hit that subscribe button, and let's continue this journey together into the vast unknown.